create a network using Ethernet ports and all of that. Still with what Windows machines, you can use Windows XP, Windows 7, or all of that. So not to say that Windows machines are network operating system fully, but they have a part of the model. A part of their module has these features, right? But it is not as strictly implemented as these other operating systems that you have up here, like Windows NT, Windows Server. These operating systems are more robust in their networking features as compared to what these ones. We know very well that when something is multi-purpose, it means that the various features, or there are some aspect of it that don't work well, or they work but they are not as strict, as efficient as others that they are tightly linked to a particular purpose. Like you have Windows Server. So take note, you should take note there. Strictly strictly having built-in networking features. You have Windows NT, Windows 7, all of that, but multi-purpose, but still having the networking features. You have the Windows 7, Windows 10, Mac OS, and all of that. So good. So you can have these logos, so you can go through and just look at these logos and all of that. Beautiful. So now it is important to know that the hardware that allows you to connect to a network that permits that you can be found in a network of computers. We call it a network interface card, an NIC, right? NIC, the network interface card. So what is it? It provides, you get the point, it provides the physical link between computer and communication medium, right? So, Emanuela or Boris, I want to connect my machine to a network, right? First, I need the communication medium, right? I need the communication medium. Maybe I'll use Ethernet cable, or I'll use two-step pair, right? I'll use two-step pair, or I'll use wireless, right? So I may use wireless channels or two-step pair cables. Now, where will I connect these cables to? You get the point. So there must be a hardware that can understand and interpret the signals when they come in, right? Because take note, the cable will just transmit the signal. Who will process it? Who will interpret it? You have what we call the NIC. So provides the physical link between computer and communication medium, right? Yes. So if I have a computer here, for instance, and I have a cable that I need to connect it to a network, of course, it should have such a port. It should have a port in it that permits it to connect to a network. So we can say this is Ethernet. So we have Ethernet port, right? So you should take note of this. So you can use Ethernet. You can use Ethernet port. You can also use your wireless NIC. You can use your wireless NIC, wireless network interface card. That's for Wi-Fi, right? Yes. So you see, you have types here: Ethernet card, total ring card, and frequency division duplexing interface card, right? So these are the various types you can have, and you basically have two kinds: wired and wireless. Yes, wired and wireless. Beautiful. So take note of that, right? What provides the physical link, right? What provides the physical link between the computer and the communication medium is what we call the NIC, right? Yes. So how does the computer receive the signal? Right? It's through the NIC, but it receives it from the medium. You get the point? It receives that signal from the medium. So without the NIC, you cannot even connect the medium towards the computer. So the NIC is very important. Now we have a hub. A hub is simply a device that broadcasts. That's all. So in a network, it receives signals and simply sends it out to other devices on the network. So if you have computer A, for instance, here, and let's say this is a hub, you have computer B, you have computer C, right? So you have them connected like this in a star topology. So if they are connected like this, right, when this computer sends, let's say computer C sends to the hub, when computer C sends a network PDU, what happens is that that data moves from the computer to the hub, and when the hub receives that data, it broadcasts. You know, to broadcast simply means to send to all other devices except the one that sent it. So I'm sending it to all other devices except C. C sent the data, right? So C will not receive it. When the hub receives it, it sends what? To B and A. If B sends it, who will receive? C and A will receive. If A sends it, who will receive? C and B will receive. So that's what the hub does, right? So only destination computer accesses. So data sent to a hub is broadcast what? To all ports, right? Broadcast to all ports except the one that received it. So that's basically how the hub works. Yes. So you should know what a hub is and how it works. So that's basically how the hub works. So we'll move to the next. Beautiful. So now we have a switch. Now just like a hub, right? Just like a hub. That's what a switch is. Just like a hub. So it means that it can receive data and what sends it to all other ports, right? But now there is something you need to know about the switch is that it is smarter. Yes, the switch is smarter. Why? Because it uses what? Switching table, storing MAC addresses. Think of this, to send data to only the intended recipient. Now you get the point that you can say that a switch is some form of what? Intelligent hub. A hub that is intelligent in the sense that it knows where to what? To send the data to the destined address. So how does it know the address? So the addressing type that is used here is what we call the MAC address. So MAC address is short for media, ignore this, MAC address, media access control. Media access. This, are you still there? Both. Boris, are you still there? Boris. Boris, are you still there? Forward it to all other or send it to all other devices on that network. No. On that sent it, right? Or except the port in which you receive the data. So when a hub receives data, it does what? It sends it to all other ports. But what the switch does is that it maintains what we call a MAC address. A switch, right, maintains what we call a MAC address. Maintains what we call a MAC address table, right? So simply to say that this MAC address table is simply what? It's, just think of it as a database having a map of what the ports and the corresponding MAC address. Boys, let's say this. Look at this is a switch, right? Let me just use this switch here. This is a switch. Let's say this computer is connected through this port. So let's say this is a computer connected to this port. Another one is connected here. Okay. So you have another. Look at this. You have, let's say, you have a third computer connected still on this same switch, but let's say connected to this port. right? So this is your network. So look at the ports, right? All these computers can communicate, right? But now, instead of the switch behaving like a hub, because the hub says that what? If A, so let's say this is A, this is B, and this is C. So if A sends data to the switch, what happens is that what? If it is a hub, take note, if it is a hub and A sends data to the switch, please bear with me. If it's a hub, right, and A sends data to this hub, what happens is that what? The hub receives it through this port and forwards it to all other ports. So if it will send the data, what? It will send it out through these other ports that you see here. That is what a hub will do. So it sends it to all other ports except the port that it received the data, right? Except this one, so it will not forward here again. That is a hub. So a hub is known to be what? A device that broadcasts. It broadcasts. To broadcast simply means that what? Send it, flood it out to what? All the ports, flood. To broadcast is to flood data to all the ports except the one that received the data. So that's what the hub will do. But now a switch, which is smarter, what it does is that what? This is what a switch will do. A switch will maintain a database. You know, you always want to call it a database because that is what the switch uses to know which port to send the what? To send the data through so that it reaches what? The destination. So there is an encapsulation process done that before the data is sent. So for the switch, before the data is sent, the data has to be encapsulated. Right? People know what encapsulation is, right? It's adding headers or tails, right? So in the data block, there is a portion of it that is we have what? The destination MAC address. So you have something des MAC address. Des MAC address. Then you can have what? The payload, right? The payload is the actual data. So you have to understand something here. When devices communicate on the network, before data is sent, right, there must be an encapsulation of the data. So what are you sending? What you are sending, the actual thing you are sending is the payload, right? And now, where is the data going to? You need to encapsulate other attributes that will ensure that what the receiving device knows how to process it. So how will the switch know how to process your data frame? How will it know? You have to encapsulate it with what? Headers. One of which you have to do is that what? You need to specify the destination MAC address. Take note, every computer on the network that is connected to the network has what? A MAC address. And that MAC address is tied to what? The NIC. We talked about the NIC here, right? The network interface card. You get the point. So it is what provides the unique value of what we call the MAC address. So the switch job, this switch as you see, needs to have a table that says that this port, it needs to have a table, and the first port, this port that we have here, let's say this is port 1, this is port 2, this is port 3, and so on. So it has to have a database, like I said, to say that port 1 is mapping to MAC address, of C. So let me say MAC C. You get the point. So MAC address, this will be 4, port 4. Port 4 will map to which MAC address? MAC address B, right? Port, so we have 1, 2, 3, 4, 5, 6, 7, 8, right? Yes. So 1, 2, 3, 4. So these 8. So you have the last port 8 has to map to what? MAC address what? MAC address A. So this is the table that the switch is maintained, and we don't want to talk about how it populates that table because there's a process there's a process of it, because imagine you just bought a switch and you connect computers to it. You think the switch already has a table? No. So there's a build-up of how the table is populated. There's a process for that, right? And we don't want to talk about it now. It's another whole course on its own. So now, this is the table. So as the switch begins to receive data frames through time, it begins to build up this table. We call it a MAC address table. Now, so much so that at some point, when A sends a data frame that has in part of it constitutes of what the destination MAC address, it simply does what? It checks the destination MAC address, it compares it across what the entries, it compares it across the various entries in what in its MAC address table. So when it matches an entry, so if it sees that the destination MAC address is for C, it's going to what? It's going to what? Send the data through what? Through port 1. You see? It's going to send the data through port 1. So that's how the switch works here. That's how the switch works. So you simply have devices that connect to the switch, make use of what? A unique identifier, right? They connect what permits that connection possibility for the devices, what we call the NIC. And to that NIC there is what? There is a unique identifier called the MAC address. So you see it is built up in what? You can see 12 digits, right? 12 digits. So these digits are hexadecimal IDs. So you have 0, 0, 1, 4. So this is a MAC address, right? So if you want to check your MAC address on Windows, you want to type this C ipconfig/all. You type this on your Windows machine, you can see your MAC address, the one that is assigned to your Ethernet NIC, your WLAN NIC. You can see all of that, right? You can see all of those MAC addresses there if you type ipconfig/all. So that is what the switch does. It maintains a database called the MAC address table, and through time, right, it begins to build up this table, and it can now receive data frames on device A. And looking at the destination MAC address, it checks across its entries and then matches it to the right port. So that is how the communication works with the switch, right? Now, if we move to the repeater, simple. A repeater is simply what expands the boundaries of wire network. So to repeat something, right, it's simply to get what you receive and what retranslate or resend it. It's simply to retransmit what you receive, to repeat. That's what it means to repeat. So if you have, let's say, a good example is when, let's say, Boris and Emanuela, let's say you are in a building where the Wi-Fi or the access point is on the first or the ground floor. You get the point. So let's say you have a building like this, and then you have different floors, this. So this is a building. So you can say this is the ground floor, right? You know what ground floor is, right? Then after ground floor, what do you have? First floor. Then you have second floor. You have third floor. And then you have fourth floor. Right? Fourth floor. Now let's say in this ground building or ground block of the entire building, you have installed an access point here. So there is an access point that you can connect to it to have. So computers on this floor, on the ground floor, can connect to it easily because it is it's not too far from it, right? So the signal strength, what we call the RSSI. So the signal strength, we call it RSSI. So RSSI is simply short for what? The received signal strength indicator, right? So the received signal strength indicator here will indicate something very high, usually in decibels, right? Decibels, intensity strength, usually in decibels. So you have that computers on this floor will have a higher value of what? of a received signal strength indicator value. But now, as you go up the building, you have the signal begins to deteriorate, right? So the signal begins to deteriorate, and let's say if you have a computer here and you really need to connect to this network to access the internet, then sorry for you, you may not even be able to detect this network. You may not even be able to detect, or you detect it, but your RSSI is going to be really low. So what then do? You can make use of repeaters, right? So I can say, okay, let me get a repeater and set it up here on the second floor. So Boris, where do you think we can put the repeater? Take note, the repeater should be placed in such a way that it can receive a signal strength that is not too low as well, right? The signal strength should be somewhat, right? The threshold should be somewhat reasonable, you see. Because does it make sense to repeat a low signal? No, right? At least you want to make sure that it is connected somewhere closer to the actual access point, right? So we can we have this Wi-Fi signal, so it can span through this building and maybe reach the second floor, right? So it can go as far as the second floor. So we can have a repeater here in this building. So you can have a repeater here. So let me type it out. Yes. So you put a repeater here in this building. It can be able to receive this signal. So it receives the signal from this access point on On the ground floor. So you notice it is not too far from the ground floor. So you receive the signal and we broadcast, we transmit it. And so when you transmit, the signals can be able to reach the fourth floor. So that's simply what a repeater does. Like you see, it regenerates signals to extend safe travel distance. You get the point? That's what a repeater does simply. Then you have a bridge, right? A bridge simply two layers. It simply connects two computer network device device one into segment. You know what a bridge is, right? The bridge, when you talk about a bridge, you have seen bridges in real life, right? Something that connects two different geographical topographies. So you have different sections in a particular area that they are not connected. So how do you make sure that people can easily live from point A to point B without separation gap? You can bridge that gap, right? You bridge it. So it's the same thing here. You can bridge two separate networks, right? You can bridge them to make them function as a single network, or you can do you can divide them into segments if you want to. So that is it for a bridge. And then we have a router. I think we'll end here. This is the last thing we'll do. We'll look at a router and what is it about the router, what's special about a router. A router is a very special kind of device, right? So what is its job? What is its role? So join several networks together and route data from one network to another. Tracks IP addresses via its network interface card and directs data packets appropriately. So that's what a router does. Its job is simply to receive data packets and route it to the appropriate destination. You get the point. So it's a bit like how the post mail system worked back in the days, where you have to go and drop your email in this building, and the first post office has to look at if they are closer to your area. If they are not closer to your area, what happens is that they send to the next post office. You get the point. So that's routing your letter. So they're just basically routing your letter. That's what a router does, right? It has the ability to look at the data packet, look at its destination. If it's not directly connected to its destination, what does it do? It checks around it, right? It checks around in any other router that is connected to it and can take that data packet to to somebody or to a router that knows something about the destination, or to the router that is there. So you get the point. So you can basically have networks like this. So let's say you have network A. So this is network A. So when I say a network, right, I can mostly be referring to what? A LAN, right? Different LANs. So this is LAN A, this is LAN B, and this is LAN C, right? And I have a router here, I have another router here, I have another router here. Look at this. This network A is connected to this router. So this is router 1, this is router 2, and this is router 3. Then this router is connected to router 2. This router 2 is connected to router 3, and router 3 is connected to what? To network C. Now let's say, provided there is a computer here in this network C. Think of these are different networks. Let's say there's a computer here to computer A that wants to communicate with what? With a different with a computer on a different network. Please, they are not on the same network. You now see why a router is very important, right? Because they said it tracks IP addresses via a network interface card and directs data packet appropriately. And what does it do? It joins several networks together, right? So this network A, this network B. The possibility of us having data sent from A to B is possible, is made possible through what? Through a router, right? So this is A trying to communicate to B, to C, sorry, but they are not on the same network, right? They are not on the same network. So which network device is best? Is it a switch? No, it's not a switch. What is best suited for this case is what? It's a router. So what will a router do? Take note, this link is not there. There is no such link here as this. I'm just trying to say that this will not work because they are not on the same network, right? This, I hope you are following up.
Yes, I'm with you.
Yes. So this is actually what I'm trying to say. So this communication is not possible directly, right? Since they are on different networks, right? Now, how will you work with routers? You basically have to forward the data through the router here. So the same thing happens. You also need to encapsulate with what? The destination IP address. Now take note, we were looking at the switch and we were looking at what? Destination MAC address. Now you're hearing something, destination IP address. That's simply to tell you that what? We have layers, right? In networks, we have what we call layers. So we are going to be looking at network layers shortly next class. So we have the OSI model, we have the TCP IP model, and then we have the hybrid reference model. So please, you are supposed to know all of these models, the various layers that are there and all of that. So in the OSI model, you have up to 7 layers, if I'm not mistaken. You have you have from bottom to top, right? From bottom to top. Physical layer, data link layer, network layer, transport layer, session layer, then you have the application layer for OSI model. The TCP IP, you have the physical layer, the data link layer, the network layer, and the application layer. Yes, so those layers are very important. Now, routers operate in layer 3. Layer 3 is the network layer. You see the network or the IP network layer, right? So that is the layer that the router best operates in, as opposed to the switch that mostly operates in the data link layer. So please, you need to take note of this, right? A switch operates in the data link layer, and in the data link layer, the unique identifier that is used to identify the different computer devices it's a MAC address, right? We use MAC addresses to identify the devices on the network when you are looking at the data link layer. But with the network layer, devices are identified with their IP addresses, right? So IP addresses. So now, this computer will have, since this is layer 3, the data has to pass through a layer 3 device, right? So it makes use of what? An IP address. So inside the payload, so you still have the payload, you have the payload, you still have the MAC, in fact, you still have the desk MAC address, because you have the data frame, basically all what you have on the data link, right? All what you have on the data link layer is still inside here. Then you have the IP. So what adds is the IP header. The IP header adds here. So inside the IP header, you have checksums, you have the destination IP address, you have the source IP address, right? All these things must be what? Encapsulated, because the router needs to be able to process the data packet and know where to route it to. You get the point. So when the router receives the packet, take note, the router also makes use of what? Of a database we call the routing table. The routing table. So it simply stores in the routing table you have IP addresses and what? And a specification of the destination, that's the destination port. So if I receive the packet of this nature, or having an IP address of this network segment, which port should I send it to, right? Or if I am not connected, if the router is not connected directly to the network that is receiving the data packet, what happens is that we talk about what we call next hop. Talk about next hop routers. Next hop. There you instead talk about what? A next hop router. Beautiful. Next hop router. So Boris and Emanuela, this is what happens. So when R1 receives this packet that is destined for what? For computer C, it processes the IP and checks across its routing table, right? It checks across its routing table, and you have routes still that the router needs to populate. So over time, there are various protocols that routers use to populate their routing tables. So it can be configured manually by the administrator, or you can set up dynamic routing protocols, right? Link state protocols and distant routing protocols. So that is also something that is going to take time, but just know that there are protocols that routers use to learn or flood or populate their routing tables, so that they receive a packet and they know where to send it to, so that it reaches the destination. So R1 receives the packet because it is not directly connected to C. What does it do? It needs to It needs to check its routing table, and on its routing table, it's going to identify the next hop. What's the next hop? The next hop is a router that is not directly connected to the destination network, right? But we need to pass through that router to reach the destination network. Now, look at this link here. This link, you must follow this link. If you don't follow this link, you cannot reach what? You cannot reach C, right? And through this link, you notice that you must pass through R2 to reach what? C. R2 is not directly connected to C, right? And because of that, the interface that is here, so you see this interface connected to R2, we are going to have this interface, we are going to use its IP address. So this interface has an IP address. So every router, right, has interfaces, and those interfaces have IP addresses. So the IP address must be set for that interface to be active. So this IP address interface here will be set as what? As the next hop. You know, the next hop address.